lesson 4-8, we're going to be finding the least common multiple of two or more numbers. We're going to be able to use the L method when finding the LCM of two numbers, but when we're looking for the LCM of more than two numbers, we're going to have to use another method because the L method just will not work for this. You'll also hear me say LCD, where D stands for denominator of our fraction. So we are learning how to define the least common multiple because it helps us with our fractions to finding least common denominators. So just for this lesson, we'll be talking about least common multiples, but then after this lesson, you're going to hear it more often as least common denominator, or LCD. When we talk about multiples, when we have twos, we have 2, 4, 6, 8, 10, 12, 14, 16, and so on. These are the multiples of 2. And then if I have the number 4, I would say 4, 8, 12, 16, and so on. And these numbers do continue. And then when we look at this, I notice that my 4s are common, and my 8s are common, and my 12s are common, and my 16s are common. So all these numbers are common multiples, but again, remember, we're looking for the least common multiple, so that would be 4. So the least common multiple, or the LCM, would be 4 for these two numbers. So looking at this example here, we have the LCM, or LCD, of 4 and 6. Okay, so if you want to separate those with a comma, you can. I know that I can factor a 2 out of both of those, and I get a 2 and a 3. And I can't factor anything else out of a 2 and a 3 because they're both prime. So typically I know that the greatest common factor, the GCF, is right here. I can find that on the left side. But when I find the LCM, or the LCD, what I can do is I can look at all these numbers. Notice I'm making an L. And what I'm going to do is I'm going to multiply all of those numbers on the bottom. So 2 times 2 is 4, and 4 times 3 is 12. So the LCM of 4 and 6 is 12. So another way you could do that if you want, we could sit here and list them all. We could say 4, 8, 12, and then we can say, well, 6, 12, 18, and we notice, oh, we noticed a common multiple, and so the least common multiple is 12. So you could think about writing them all out like this, but you know, for these numbers, they're pretty small, so it's kind of easy to see that 12 is going to be the least common multiple. But as we start working with bigger numbers, you're going to want to have a method to use in finding the LCM, or the LCD. And so the L method is a useful tool for us since we already know how to use it. Now we just need to know and remember how to use the L method to find the LCM, the least common multiple. So for example 2, we're going to use 4 and 15. So we'll write those two numbers into our L method. And when I'm thinking about this, okay, 2 can go into 4 but not 15, and 3 can go into 15 but not 4. So there's really no numbers that go into both of these. And if that ever happens, the least common multiple can simply be found by multiplying these two numbers together. So 4 times 15 is 60, and the LCM of these two numbers is 60. So this is kind of an example here of writing them all out. You're not going to want to sit here and write 4, 8, 12, 16. You're not going to want to write that all the way out to 60, because that's going to be the first time that those numbers cross paths. So 15, you would have 15, 30, 45, and then 60. So it doesn't take a whole lot of time to do them and list them all for 15s, but counting up by 4s is really going to take a long time, and it's much faster for us to use the L method. Understand that those two numbers really can't be broken down any further, and so we just need to multiply the two together to get 60. That happens with pretty much all of our numbers. To find a common multiple, you could take 4 times 6, and 4 times 6 is 24, and this would be a common multiple, but remember, we want to find the least common multiple. So if you can break the numbers down, we need to do that, but in this case, we couldn't break the numbers down any further, So therefore, we just need to multiply the two together. So now we're getting into more than two numbers, okay? And whenever you find the LCM or the LCD of more than two numbers, first of all, you can, if you want to, you can try to think about a number that would work. Looking at 22 and 33, I know that probably 66 would work, but 44 is not going to fit into 66. So if you can think of one quickly, you can do it kind of in your head. But I'm going to show you a way that we can do it by working it out. So we're going to have 22, and then we're going to do 33, and we're going to do 44. Notice I'm giving a lot of space in between all of these because we actually need to do prime factorization of all of them. And, you know, looking at these numbers, it's not going to take a whole lot of time. We have 2 times 11. So I'm just going to write 2 times 11 down here. And then right here we'll have 3 times 11. So that'll be 3 times 11. And here we're going to have 4 times 11, but then we need to break that 4 apart into 2 times 2. So what I did forget to do here is circle all my primes. They were all primes, so that's kind of why I didn't do it. But here now I have all these primes. Now when we rewrite this, I'm going to have 2 squared times 11. Now the thing is, when you go through and rewrite the to find the LCM of these three numbers, what we want to do is we want to include one prime number from every one of our numbers. Every number needs to be represented. So I have a 2. So I need to write the 2 down, but then I want to use the largest 2 that we have. So this is just 1 2, and this is actually 2 squared. So I'm going to use the 2 squared because this one kind of covers that one also. So my 2's are done. Okay, and then my next number is a 3. So I'm going to look around to see if I have any other 3's, and I don't, so the 3's are gone. And now I'm going to check, okay, I have an 11. This is 1, 11, this is 1, 11, and this is 1, 11. So I'm just going to use 1, 11 because that's all the bigger it was. The reason I use 2 squared is because 2 squared is bigger than 2 to the first. So what I need to do is I need to work this out. 2 squared times 3 times 11. So 2 squared is 4, and 4 times 3 is 12, and 12 times 11, if I bring this down, 12 times 11, well, if I want to, I can go ahead and jump to a calculator. 12 times 11, and that equals 132. So 12 times 11 is 132, and that is actually going to be my LCM of this problem. So when looking at these three numbers, it would have taken them quite a while for me to list all the numbers for all the multiples of 22 to get all the way up to 132. It would have taken me quite a while, and then I would have had to do it with 33 and 44, and so that just takes up a lot of time and a lot of space on paper. So what I need you to do is use this prime factorization method. Again, we're looking for every number to be represented. So I had a 2, so I need to have a 2. I have a 3, so that's got to be in there. I had 11, so that needs to be in there. If I would have had a 7 somewhere or a 5, I would have needed to include that as well. And then you're going to use the largest one. So that's why we use 2 squared rather than just 2. So let's try another example of that here with this word problem. We have machine A must be oiled every 18 minutes. So I'm going to write an 18 down here. And then machine B is every 24 minutes. And machine C is every 48 minutes. So I need to find the least common multiple of all three of these numbers. So when I break these apart, I'm going to get 3 times 6. And so I'll circle the 3. And then I'm going to get 2 times 3. And then I'll rewrite that as 2 times 3 squared. So here I have a 3 squared, so I might be using that later, but we'll find that out as we go. So then I can do 2 times 12, and 2 is prime. And then I can do 2 times 6, again, the 2 is prime. And then I can do 2 times 3, where the 2 and the 3 are both prime. So when I rewrite this problem, I'm going to get 2 to the 3rd power times 3. So now I actually have a 2 to the 3rd power, so I won't use that 2, and then I have a 3 squared. But I still have one more number that I need to break down before I can figure out what I'm going to use. So I'm going to go with a 2 times 24, and the 2 is prime, and then 2 times 12, Again, the 2 is prime. And then I can do I'll switch colors here just so we can see it, a 2 times 6. Again, the 2 is prime, and then a 2 times 3. And both of those numbers are prime. So let's rewrite it as 2 times 2 times 2 times 2. So that's 2 to the 4th times 3. So now again, when I rewrite it, I know I'm going to have a 2. And am I going to use 2, 2 to the 3rd, or 2 to the 4th? Well, I need to use 2 to the 4th because it is the biggest one. And then I'm going to have a 3. And am I going to use 3 squared, 3, or 3? Well, I'm going to use 3 squared because it's the biggest one. So 2 to the 4th, well, 2 times 2 is 4, times 2 is 8, times 2 is 16. And 3 squared is 9. So I need to do 16 times 9. Well, if I want to, I can always jump onto a calculator to do 16 times 9, and that gives me 144. So as we look at this, 144 is the least common multiple. So what that means is if I oil all 3 machines at the same time, it's going to take 144 minutes. So I do want to include the units there. So 144 minutes. It's going to take 144 minutes until all 3 of those machines are synced at the same time, where I have to oil them all at the same time again. So again, it's going to take quite a while if I want to sit here and list out all the multiples of 18, 24, and 48 until I finally get to 144. That's going to take quite a while. So it's much easier to just list the prime factorization and then figure out what numbers we need to use. Again, if I would have had any 5s, 7s, or 11s in here, I would have needed to include them, but I didn't have any of those. So I just used the ones that I had, and I used the biggest one. So 2 to the 4th was the biggest, and 3 squared was the biggest. And the other ones, they'll all fit in there. The reason I can't use the L method is because actually I would end up multiplying by all of these numbers, and my number's going to be a lot bigger than 144, and that just won't work. So Brenda put up 3 different strands of decorative blinking lights. The first strand blinks every 6 seconds, so I'll write that down. We have 6 seconds. And the second strand blinks every 8 seconds, and the third strand blinks every 4 seconds. So some of you may be thinking right now of a number that all 3 of these numbers are going to have the same multiple of, and that's a good thing. You know, hopefully we start thinking of that quickly. But again, this is more than 2 numbers, so we have to use the prime factorization method. We have 2 times 3, and then we can do 2 times 4, and then we'll break that apart into 2 times 2, which all of these are prime. So let's rewrite those before we get ahead of ourselves here. We can do 2 times 3, and then we'll do 2 to the 3rd, and then we split up that 4. We know it's going to be 2 times 2, which is 2 squared. So right now I know I have to use a 2. 2 to the 3rd is the largest 2 I have. And then I only have 1 3, so I'm going to use that one. And 2 to the 3rd power is 8 times 3, and then we have 24. So 24 seconds. We look back at our problem because they were blinking in 6, 8, and 4 seconds. So in 24 seconds, all 3 strands will blink at the same time, and then they won't blink at the same time again for another 24 seconds. So again, what I said was right away, some of you may look at 6, 8, and 4, and you might say, okay, I know that 6 and 4 make 24, and 8 also has 24 as a multiple. So you may know that right away, but this is still the work that I need you to show, so that way I know you understand how to do the work and how to work it out in case you didn't understand that those were the numbers right away. So please make sure you're showing all your work and taking us through it step by step. Using the prime factorization method for more than 2 numbers, and you can use the L method when it's just 2 numbers. And that is our last example for today. So if you want, you can check out the online personal tutors. Just keep in mind, they won't show you how to do the L method for just two numbers. They'll probably use prime factorization for all of this assignment, which you could do that as well. Or you can check the step-by-step homework helper if you have any questions with the homework.